acid or base. That's the purpose of it. The pH determines whether your body is acid or base. Bottom line. Okay? And if your pH, or any pH in the human body, runs between 7.35 and 4.5, it's considered normal. And basically what the pH is reflecting is hydrogen ion activity. You can actually look like the partial pressure of the hydrogen ion. This determines your pH. So when you look at a blood gas and you see the pH, you look at the pH and you make sure you determine whether it's normal, and if it's not normal, is it acid or is it base? Okay? And it's based upon the hydrogen ion activity. All right? So a pH less than 7.35 is acid. So like we have a pH of 7.09 or 7.23 or 7.33. All of these pHs are below that, so it's an acid pH. All right? All right, we'll talk about the hydrogen ion activity. So I asked you on the quiz when the hydrogen ion activity or hydrogen ion is increased. The pH and the hydrogen ion are inversely proportional. So when this pH is less than 7.35, the hydrogen ion is elevated. It's too many hydrogen ions. And when it's too many hydrogen ions in the body, it makes the pH drop below 7.35. So by definition, an acid pH, you have an increase in hydrogen ions. Any questions? See, you've memorized good, right? You took the quiz. Now we're going to understand why. So that's acid. Okay, anytime the pH is greater than 7.45, that's a base, or we can call it alkaline. Most of the time we'll use base, but it means alkaline. These two words are interchangeable, alkaline. And since the hydrogen ion and the pH are inversely proportional, in this case, it's not enough hydrogen ions. There's a decrease. So when you have a decrease in hydrogen ion, it makes your pH go up. Now, there's a lot of reasons, and we're not going to get into pathophysiology. I'm just teaching you blood gas interpretation. There's many reasons why this would be acid and why this would be base. We're not concerned about that right now. I want you to understand how to interpret blood gases. And by no means will you be finished with blood gases this semester. Next semester, patho. Following that, mechanical ventilation. They all tie in. Okay, so it's different reasons for this. So what you need to understand, number one, when the pH is less than normal, it's acid. And number two, the hydrogen ion activity is increased. And then when the pH is greater than normal, that's base or alkaline. And the hydrogen ion activity is decreased. So what does a pH do? It measures the acid-base or determines the acid-base balance in your body. How does it do it? It's monitoring the hydrogen ion activity. That's how it does it. There it is right there. Any questions? Okay, so that's what a pH does. So your pH will be either normal, it will be acid or base. It cannot be acid and base at the same time. Cannot be. So when you get a blood gas, you're going to call it what it is. You get a pH of 7.09, that's acid. How do I know it's acid? Because the pH value is less than normal. So here, now you have to know what normal is. All right. If I get a pH 7.23, same thing. Pretty bad. This one is really bad here. This one is real bad, real. This one not so bad. That one's bad compared to normal. Okay. Okay, so the pH and the hydrogen ion are inversely proportional. When the pH is down, the hydrogen ion is up. And I know that's acid. And then when the pH is down, when the pH is elevated, I know the hydrogen ion is down, and I know that's base. And so that's why we call it acid-base balance. And the only time it's normal is when it's between those two values. Okay, so what does the pH reflect? Acid-base balance. When you look at a pH, you call it acid, you're going to call it base, or you call it normal. Okay, and the hydrogen ion is inversely proportional. So if I give you a question and I say that the hydrogen ion is decreased, what are you going to tell me about the pH? Is it base? Very good. All right, any questions? Okay, moving on. And this reflects the handout that I gave you. This does reflect it. And I'm going to have others for you, but I just want to take it slow. There is a chapter in Egan's, and there is a chapter in cardiopulmonary. If you don't even have to read it, if you do it this way. And this is not the only way, but I was challenged about, not personally, but professionally, about, I don't know, 5 or 6 years ago, and some clinical sites said that students can't learn or not supposed to be learning ABGs the first year. And I said, okay, watch. So when you go to clinical in the winter, you'll know blood gases. Not extensively, but you'll be able to take the blood gas, break it down, and interpret it. Okay? So that's pH. Next, and generally we write it like this. This is partial pressure. Ooh, fancy peek at me. That's pressure. This is not amount, that's pressure. This little a is arterial blood, carbon dioxide. So this is the partial pressure of carbon dioxide in the arterial blood. Not the amount of carbon dioxide, but the pressure that it exerts. It's the difference between volume, pressure, and flow. And we'll get into that in module 1. The amount of something, the pressure that it exerts, and how fast it moves is 3 different concepts. Okay, so this is pressure. That's what that P stands for, little a, arterial blood. And why I'm giving you this, because this big A is alveolar. These are 2 different things. I'm just writing it. This is partial pressure of alveolar O2. This is partial pressure of arterial O2. These are 2 different things. So my point is, this is arterial. Okay, little a is arterial, big subscript or capital subscript A is alveolar. There is a difference. Okay. This is the how much CO2 in our body. How do I put this? Yeah, I know how to put it. Okay, in our body, everything that's metabolized is broken down. And anything that has to be excreted in our body is excreted 1 or 2 ways. One way, the majority way, the acid in our body, the whole function of everything being broken down in our body is for acid to be excreted. The most common way is through our kidneys, and we urinate. That's the most common way. That's how we excrete acid through our bodies, and we'll get there. But another way is through the lungs. And so when we talk about a PaCO2, what are we talking about? Layman term is breathing. Term we're going to use is ventilation. So when we look at a PaCO2, it reflects how well a patient is ventilating. And ventilation means moving air in and out of our lungs. When we inhale, what are we inhaling? Oxygen. So the first part of inhalation, or ventilation I should say, the first part of ventilation is inhaling or inspiring. Make sense? You can say either one. One is Greek, one is Latin. Who cares? Inhaling or inspiring. We inhale or we inspire air. And when we do that, we take in oxygen. Right? When we exhale or expiration, we exhale CO2. That's the only purpose of our lungs. It's a big responsibility, though. The only purpose of our lungs is to inhale air from the atmosphere and exhale air from our lungs. When we inhale, we're inhaling oxygen, and when we exhale CO2. And that process together, inspiration and expiration, we call ventilation. Okay, and why am I going through this? Because our body excretes acid two ways. The most common and the majority is through the kidneys. And we'll get there when we talk about bicarb. But another way our body excretes acid is when we exhale. And when we exhale, that acid is now in the form of carbon dioxide. When we excrete acid through the kidneys, it's in the form of urine. It's liquid. So through the kidneys, our acid is liquid and we urinate. In the lungs, it's a gas. And every time we exhale, we're exhaling a gas, CO2. So when it goes in, it's oxygen. But because we're human, I don't want to say human, but because we're a living organism, yeah, there you go, and we have waste, when we exhale it, it's carbon. Anything living produces carbon in their body. And so we exhale CO2 in the form of a gas. So we excrete acids through the kidneys, and it's called urine. And then we excrete acid through the lungs, and it's called carbon dioxide. So back to this. When we look at this, what are we looking at? We're looking at how well the lungs have ventilated. We're looking to see how well the lungs is moving this carbon dioxide out. Does that make sense to everybody? Everybody clear on that? So when we look at a PaCO2, it's for ventilation. So let's talk about this. Normal respiratory rate is 12 to 20 breaths per minute. That's normal ventilation. For some of you, maybe 12. So for some of you, you could be outside the sandbox and your respiratory rate, normal respiratory rate could be 22. That's normal for you. Well, whether our rate is 12 or whether our rate is 20, normal PaCO2 is 35 to 45. And how I remember, I look at the pH and I just take the 7 off. And it's the same numbers. Just take the 7 off. 7.35, 7.45. But because it's a pressure, it's millimeters of mercury. And the fine gentleman, whether physicist or whomever he was, his name was Torricelli. So they honored him, or so you can call it millimeters of mercury or Tor, but nothing else. Either one is fine. Okay, he came up with millimeters of mercury. Isn't that wonderful to be honored? So don't let that confuse you. When you go for your boards, you're going to use TOR. Okay, so when I look at the PCO2, I'm not looking at the amount of CO2. I'm looking at the pressure that it exerts. If it's between 35 and 45, I know this patient is ventilating just fine. They're not having any problem breathing, or they could, and something has been going on. All right? Okay, but now, if respiratory rate is 12 to 20, we call this ventilation. Let's deal with 35 or less. No, I'm going to deal with 45. 45 or greater than 45. Greater than 45. When the PCO2 value comes back greater than 45, let's say it's 55, okay? That's considered an acid. And so go back and look at your hydrogen ion. When there's too much acid in the body, what's the activity of the hydrogen ion?
It's decreased.
Increased. Increased hydrogen ion, right? Everybody see that on your notes? Everybody with me?
Yep.
Okay. Meaning that the PCO2 in the arterial blood is higher than 45. That means it's an acid. By definition of an acid, it's the activity of the hydrogen ion, right? When you have an acid condition in the body, the hydrogen ion is increased, right? So where is the pH? Decreased. And so when we look at a PCO2, we don't call it, it's reflecting ventilation, how well a patient is moving carbon dioxide out, but we call it respiratory. And we know that's in reference to the lungs. We use this term respiratory. Okay, so I'm going to put all this together. I have a PCA2O value of 55 millimeters of mercury. I look at this and I say it's greater than normal, so I know it's acid. If it's greater than normal, I know my hydrogen ion is increased, and therefore I know my pH is decreased. So I can then now call this respiratory acidosis. So a PCO2 value greater than 45 gives you respiratory acidosis. And if I need to repeat myself, let me know, because we've got a long train ride.
You said respiratory acidosis?
Respiratory acidosis. Okay, so let's go back. When I look at the PaCO2, Kelly, where's Kelly? Tell me what this acronym is, or this abbreviation means.
It means that is the partial pressure of carbon dioxide that's present in arterial blood.
Very good, very good. Okay. All right, Jennifer Moore. What's normal PaCO2 value?
35 to 45 millimeters of mercury.
Okay, very good. Ebony Richardson. Ebony? Oh, okay, Ebony. Okay. When a PCO2 value is greater than 45, what does that mean? Acid or base? Acid. And so because we know that the PaCO2 reflects carbon dioxide, our ability of the lungs to excrete carbon dioxide, what kind of acid do we call it?
Respiratory acidosis.
Absolutely. Any questions? Okay. Maria, when we have respiratory acidosis, what is the activity of the hydrogen ion? it's increased. Just that simple. Okay? Any questions? All right. So back to this medical, we call it respiratory, but what's going on physiologically? Well, when we adequately ventilate, when our body adequately excretes CO2, that value would be between 35 and 45. However, when we have respiratory acidosis, clinically we can call it something else, and I'm going to get started. Well, I'm crossing wires here. This won't happen until Module 2 in cardiopulmonary NP, but you'll be a step ahead. When that PCO2 is greater than 45, we know it's respiratory acidosis, right? We all said that. I'm just repeating myself. Because it's respiratory acidosis, we know the hydrogen ion is increased, we know the pH is decreased, and we call it respiratory acidosis, right? Okay, so that means from a perspective that the patient is not adequately ventilating. And so when a patient doesn't adequately ventilate, and now I'm going to start giving you synonymous terms. I can look at a PCO2 and I can only tell by looking at a PCO2. I can't look at a patient and say, oh, I see. No, you can't. You got to have a blood gas to do this. But if I see the PCO2 is greater than normal, I can say the patient is hypoventilating. Hypo. Now, it may sound weird because you want to think too much. The patient is retaining too much, but they're not blowing it off. So they're hypoventilating or hypoventilation.
So they're retaining more?
Yes, the value in their blood is greater than 45, so they're retaining too much. So what does that mean for the lungs? The lungs are not adequately excreting CO2, so we refer to it as hypoventilation. Now, when I say this, I'm not talking about a respiratory rate less than 12. That's not what I'm talking about. Okay? And maybe I better clarify. Okay, we have normal respiratory rate 12 to 20. Everybody with me? When the respiratory rate is greater than 20, we call that tachypnea, not tachypnea. And perhaps you learned it that way, but I'm correcting you now. It's tachypnea. See the nia? Nia has to do with air, rapid rate, when the rate is 12. This is not hypoventilation. You have to have a blood gas to see what this PCO2 is to call it hypoventilation. Okay, when the respiratory rate is less than 12, this is bradypnea, not bradypnea.
You said less than 12?
When it's less than 12, what does Brady mean?
Slow.
Slow. Respiratory rate. Just because a person has a rate of less than 12, it doesn't mean they're hypoventilating. I don't want you to get this mixed up now. I can count a patient's respiratory rate. I can count your respiratory rate. And I can say whether it's less than 12, and I can call it bradypnea. I can say it's 14 and is normal. That's eupnea. A normal respiratory rate is called eupnea. Or I can say it's greater than 20. That's called tachypnea. But I cannot say whether it's hypoventilation, and then we'll get the hyperventilation, unless I look at a PCO2. So how am I going to make this call? I have to have a blood gas. What am I saying to you? I am saying that you can't look at a patient and say they're hypoventilating. You can't look at a patient and say they're hyperventilating. You have to have a blood gas, a PaCO2. Everybody got that? We're very technical. We're very specific in respiratory care. So you can't just look at a patient and say, oh, they're hypoventilating. How do you know? And the reason is you can have a patient in distress. Normal respiratory rate is what?
20.
You can have a patient having a respiratory rate of 50 breaths per minute and their PCO2 be 85. Their respiratory rate, they're tachypnic, but their PCO2 of 80 says they're hypoventilating. Does that make sense?
Yes.
I'm breathing fast, but I'm not ventilating enough. So don't confuse these two terms with this. You must have a blood gas to make this call. So this is a synonymous term for respiratory acidosis. So respiratory acidosis is the ABG interpretation. But clinically now, I can say this patient is hypoventilating, and it doesn't matter what his or her respiratory rate is, because I have a blood gas to substantiate this. Does this make sense to everybody? If you don't understand, please ask me questions. Everybody got it? All right. So, yes.
Like if the respiratory rate is like above normal, like more than 20, and the carbon dioxide, partial carbon dioxide is in normal range, then we only call it in tachypnea.
It's not tachypnea. It is tachypnea. Yes. Yep. So ventilation could be normal. They just have an increased respiratory rate. Now that increased respiratory rate eventually is going to do something depending on what it's caused. But if that PCO2 is between 35 and 45, ventilation is normal. And that's all you call it. Okay? All right. So, what's a synonymous term for respiratory acidosis? Hypoventilation, meaning the patient is not adequately blowing off CO2. They're retaining it. And that's not good for whatever reason. So if they're retaining it, you're going to see a value greater than 45. And you have a typical patient, you're going to learn about COPD patients. They're called CO2 retainers. They can never blow off an adequate amount of CO2. I'm not expecting you to know that as of yet, but that's a typical patient. They always hyperventilate. Yes?
Did you say that the breaths per minute are not always changed by the PaCO2? Like you can have a...
Right.
Okay.
It's irrelevant. You can have a respiratory rate. A patient can be in distress and have a respiratory rate of 50. Now, normal rate is 20. They can have a respiratory rate of 50 and a PCO2 of 80.
Okay.
According to that PCO2, they're still hypoventilating.
Is there a machine that makes that for
Yeah, blood gas machine. Yeah, you get the blood and then you run it, or somebody does the puncture and run it, and then whether you do the puncture or run it, you have to interpret it. Yeah, it's a machine that does it. Yeah. Okay, everybody got this? Okay, so when a patient doesn't adequately ventilate, what does it do to the pH? It drops the pH and it makes the hydrogen ion go up. So when a person hypoventilates, it causes respiratory acidosis. And again, this may be irrelevant, how many times they're breathing per minute. We're looking at something else to assess how well they breathe. So again, layman term is breathing, we say ventilate. And when we're looking at a blood gas, we refer to it as respiratory. So when I say respiratory, what am I talking about? I'm talking about the lungs. How well the lungs are ventilating. Here, not so good. If the lungs are not ventilating adequate, meaning the patient can't excrete CO2, then this PCO2 value will be greater than normal. So hypoventilation is a clinical term. Respiratory acidosis is an ABG term, but they can be used synonymously. It depends on the author. So it doesn't matter whether the author says the patient's in respiratory acidosis, you know the patient's hypoventilating, right? It doesn't matter where the author says hypoventilation, then you know, you may not know exactly what the pH is, but you know the pH is less than normal. Got it? Yes, ma'am. Oh, I thought you had your hand up. All right. When you raise your hand, just tell me your name. I'll get it. Okay, I'll get it. Any questions? Everybody say tachypnea.
Tachypnea.
Don't tell me tachypnea. Tachycardia is correct, but not this. Our instructor told us tachypnea. Irrelevance. You're in respiratory care now. Okay, and let me do bra. So the Y is silent here. So it's tachypnea, brunipnea. That's how you say it. Tachypnea, brunipnea. Tachypnea is a rate greater than 20. Brunipnea is a rate less than 20. You cannot count a patient's respiratory rate and assume their ventilation. You must have a PCaO2. And then once you have the PCaO2, you can determine whether it's adequate normal ventilation, hypoventilation, and then the next one, hyperventilation. Got that? It is two different things, because you will have patients, as I described, that will have a respiratory rate of 50, and that's tachypnea. But their PCO2 can be 80, and they're not adequately ventilating, they're hypoventilating. So I don't want you to think that everybody who's tachypnic is hyperventilating and everybody who's brunipnic is hypoventilating. That is not true. It's the exact opposite. Yes.
Is brunipnea less than 12 or less than 20?
It's got to be less than 12. Greater than 20 is tachypnea.
Okay, so less than
12 to 20 is normal. So if it's less than 20 and it's 16, 16 is still normal, right? It's less than 12. Okay? So this is greater than 20, and this is less than 12. Breaths per minute. Yes.
So for the partial pressure for the carbon dioxide, if it's a less than 35, is it still what's that called?
Hold your horses. We'll get there. All right. Any questions? All right. I want you to understand very clearly that these are two different things. You can only determine how adequately a patient ventilates by their PaCO2. Counting the respiratory rate is wonderful, and we do that. But you can't make that call whether it's, because when you say hypoventilation, technically you're saying a patient's in respiratory acidosis. I can't look at this young man and say he's in hypoventilation. How do I know what his pH is by looking at him? Make sense? I must have a blood gas to make that call. But I can say he's hyperventilating or hypoventilating, but that's irrelevant without a blood gas to make the call for his acid-base balance. That's two different things. All right. Okay, how do you say this? A rate greater than 20?
Tachypnea.
Tachypnea, and a rate less than 12?
Brunipnea.
All right, I don't want to hear bradypnea and tachypnea. I don't want to hear it. All right, so now I'll leave that there. Okay, so now the opposite, 35 to 45, adequate ventilation. Ventilation really reflects, when we're looking at a PCO2, how well the patient is exhaling CO2. That's what we're looking at. When we say we're assessing ventilation, is how well the patient is exhaling CO2. All right, so now we have a PCO2 less than 35. Okay, when it's less than 35, then we call this respiratory alkalosis, which is a base. And so if it's a base, August?
Yes.
Oh, okay, August.
It's Mendelssohn, the first name. August is the last name. I know everybody confuses it. It's okay.
Okay, Mendelssohn.
Yeah.
All right, so I'll get it right. If we have a patient that is in respiratory alkalosis, and we know that's a base or alkalitic, what's the activity of the hydrogen ion?
The hydrogen ion is decreased.
Good. The hydrogen ion is decreased, and then if the hydrogen ion is then decreased, what's the activity of the pH?
pH is increased.
Very good. The pH is increased, meaning that it's greater than 7.45, right? Because that is alkalosis. Everybody got that? Any questions with this? You may write it different from I do, but the information is here. And so, if a patient's PCO2 is less than 35, that means that they're blowing off too much CO2. They're not keeping it. It's less than normal. What are they doing? Hyperventilating. And again, this doesn't have anything to do with tachypnea or bradypnea. They're blowing off too much CO2. They're not keeping enough in. And because they're not keeping enough in, the hydrogen ion is decreased and it's upset acid-base balance. And so they're blowing it off. So acidosis means a patient is retaining CO2, they're keeping too much in, and they hypoventilate. Respiratory alkalosis is the exact opposite. The value is less than 35. So I'm talking about a PaCO2 of, let's say, 28 or 25, and Lord forbid, 20. All these values are respiratory alkalosis. And so my clinical interpretation of that would be hyperventilating. Does that mean their respiratory rate is greater than 20? It does not. They can have a normal respiratory rate and yet be hyperventilating. Because when we talk about ventilation, it reflects the activity of CO2. Yes, sir.
Just answered my question for me.
Oh, okay.
So what's happening when the rapid ventilate? They're not holding anything?
No, you're blowing it off for whatever reason. It's a lot of pathophysiology behind it. I'm not getting into that right now. But it could be medicinal reasons. It could be medication. It could be a response.
You
Yes.
had said, when you put 20 down, you said, Lord forbid. So if somebody's at 20, I mean, is that fatal? I mean, if they're...
Depending on what's going on. It's severe if you look at 35 normal, and then their PCO2 has dropped 15 millimeters of mercury. It's a lot going on. And hopefully we can do something about it, hopefully. Or it could be medicinal. It's a big difference between 15 millimeters of mercury. Yeah. I'm not going to get into the reasons. I want you to learn blood gases now. Next semester, we'll get into the pathway. All right.
Ms. Mill?
Yes. Tell me your name.
I'm Kelly.
Kelly.
I just wanted to clarify also, do they also switch the names around? Respiratory alkalosis also means hyperventilation?
Yes, this is synonymous. Yes,
Also
these are
synonymous.
synonymous. Yes, ma'am. These are synonymous. Yes.
Thanks,
Tell
Doyle.
me. Doyle?
Yep.
Okay.
So basically, when you're looking at somebody's breathing rate, you're just trying to get to, if somebody comes in, you just see they're either breathing really hypo or hyperventilating.
No, no,
I
you
mean-
cannot make that call unless you
No, I
have
mean,
a
if you just
blood
look at the rate, I'm
gas.
saying, if you're looking at the rate and you time the rate, it's over 20, less than 12.
Then you call it tachypnea.
Then you do the next step would be obviously go to a gas test and go from there.
If that's, if
If
it's
that's
an
the
indication, yeah.
So all you can do basically is all you're doing is timing visually, and all that is a starting point that they're either breathing too fast, too slow, and then you go from there.
Yeah. You can't talk about ventilation unless you have a blood gas, yes.
My name is Heather.
Heather.
I was just curious, why is it millimeters of mercury?
Because Torricelli made the units that
Oh.
way. Barometric pressure is millimeters of mercury. The only thing that we use the English system for is PSI, pounds per square inch gauge. Everything else is English or metric system. We honor physicist Dr. Torricelli because he came up with millimeters of mercury, and we use it in a lot of areas. That's all I do. Millimeters of mercury reflects pressure. If that's the most specific I can be. When we do a blood pressure, it's millimeters of mercury. When we listen to the news and the meteorologist talks about barometric pressure in the atmosphere, it's millimeters of mercury. Yes. Okay? So millimeters of mercury reflects pressure. All right. So now you've learned about hyperventilation and hypoventilation. So what I want you to get is, if I ask you, what is the acid-base balance for hyperventilation, you're going to tell me what?
Oh.
What is the acid-base balance or acid-base interpretation for hyperventilation?
Less than equals 33.
What's the acid-base interpretation? Everybody is going to tell me respiratory alkalosis.
Okay.
Okay? If I ask you for the acid-base interpretation for hypoventilation, you're going to tell me?
Respiratory acidosis.
Okay. Why is it respiratory? Because ventilation reflects the lungs. Got it? Tachypnea, bradypnea have nothing to do with assessing ventilation. It may oxygenation, and I'll get to that, but not ventilation. It's two functions of the lungs. One is to inhale, and when we inhale, what do we inhale?
Oxygen.
And when we exhale, what do we exhale?
CO2.
And together, inhale and exhale is called what?
Ventilation.
And when we look at an acid-base termination and we refer to ventilation, what part of ventilation are we referring to? Exhalation.
Exhalation.
Why do we exhale CO2?
It's the
It's
waste.
a waste product. And what kind of waste product is it? It's an
Acid.
acid. What other way is acid excreted from our body?
Urine.
Urine, through the kidneys. Got it? So we have two ways acid is excreted from our body. In a liquid form, through the kidneys, called urine, and in a gaseous form, through the lungs, called CO2. When we look at a blood gas, we're not looking at the amount of CO2, we're looking at the pressure it exerts. The amount is irrelevant. As long as we can see the pressure, we know how well the lungs are handling things. And everybody that you'll see in these conditions, their primary problem won't necessarily be respiratory. It could be something else. It could be a diabetic. It could be head injury. It could be GI problems, and it will reflect acid-base balance. Okay? All right, I'm going to give you another term. The medical term for carbon dioxide is called carbia and capnia. These are both for CO2. Capnia, that's a CA. And carbia, see the carbon right there? And cap is referring to breathing. So it can be carbia or capnia. That's for CO2. I'm giving you medical terms now. These are synonymous terms. So let's go back to respiratory acidosis. Everybody with me? Okay, one term, clinical term, you've learned about respiratory acidosis is hypoventilation. Yes? Another term, now watch this, hypercarbia.
Carbon.
Too much carbon dioxide in the blood. Hypercarbia. Too much carbon dioxide in the blood. Hypercarbia. If you see that term hypercarbia, what does it mean?
Too much
Respiratory
carbon.
acidosis. Too much. PCO2 greater than 45. Okay? Another term, hypercapnia. All three of these terms are synonymous.
And what's, well, hypercapnia refer to respiratory acidosis? Okay.
Any one of these means respiratory acidosis. The patient's hypoventilating, but I can tell you the patient's hypercapnic. And if I say hypercapnic, you know that they're hypoventilating, and you know they're in respiratory acidosis. Therefore, the PCO2 is greater than 45. Any questions? All right. So the same thing over here. This is hyperventilation, right? But these two terms now are hypo. Hypocarbia. Not enough CO2 in the blood. And hypocapnia. So hyperventilation, hypocarbia, and hypocapnia all mean respiratory alkalosis. These are synonymous terms. Does everybody see? Now don't see, when we talk about ventilating, we're saying they're hyperventilating. They are. But from a perspective of what's in the blood, it's not enough. Because they're blowing too much off. So then we call it hypocarbia or hypocapnia. Over here, they're hypoventilating because they're retaining it. And when we look at these terms, there's too much CO2 in the blood because it's more than normal, or too much, same thing, CO2 in the blood because it's normal. Does that make sense? These are medical terms, and in respiratory therapists know these terms. So start making flashcards, index cards, whatever you need to do.
Respiratory acidosis is hypo. Is the other one PCO2?
No, ma'am, I just explained. This is in the blood. PCO2 is greater than 45. Too much CO2 in the blood. Too much CO2. No, it's not. That's why you're here in class. You'll get it. If you think it's confusing, it's going to be confusing to you. If you get it straight, look at what it means. This is in the blood. Too much CO2 in the blood. Too much CO2 in the blood. Not adequately ventilating because it's too much CO2 in the blood. Got it? Any questions? All right. Acid-base balance to beginning. Now, the next time we do it, I'm not going to tell you we're going to do it tomorrow. I don't know. We may do, I don't know, maybe Wednesday or Thursday. Have your notebooks for acid-base balance with you every day. And what I'm gonna do, fair game, since I am teaching Monday, Tuesday, Wednesday, and Thursday, even though we may not cover acid-base balance, certainly in the morning, even though it will be pharmacology time, if you have any questions on any material that I cover on acid-base balance, that will be the time to ask. And from this point on, you may not have this handout. Some of them were gold, some of you had gold. Did anybody